is David, are you coming back up? Is that what I understood? Following Ted Blank. You're going to do trying to hit the flat areas of grazing occultation profiles using Kaguya data. Sounds Hindu or Indian. So
Japanese.
Japanese. Okay. So let me give the microphone to David.
Okay. Yeah. Kaguya is the name of the Japanese spacecraft mission that orbited the moon for several years in the early 2000s and mapped the moon in much greater detail than had been done before. Clementine did a rough map, but they had a much more capable laser altimeter that stayed in lunar orbit for over a year and allowed us to get profiles that were finally much more accurate than things from before. So anyway, if we could just go to the next slide. I have this is a presentation I've given before, and so I'm going to switch through the first general slide. Just go to the next one. You've all seen the geometry of a grazing occultation at the northern and southern limits of the occultation. See, there's a laser pointer somewhere here. Here it is. Okay. So, okay. So, okay. Anyway, I think everyone here, I think, is familiar with that geometry and how you set up observers across the predicted path. You have a line, the predicted northern limit line, which is offset a little bit because of just the prediction differences here, but it would normally be just tangent to the disk of the moon for the mean limb of the moon. But then the moon is not perfectly smooth. Instead, you have all these mountains and craters that cause a profile. And we had predictions from the Watts charts before, which you could see are these dots scattered around, but the real profile of the moon is much more rugged. And so this is just time versus time of closest approach for each observer, minutes before and after central graze, and this is their distance then from the limit, 2 miles. But there's a huge difference in the vertical scale versus the horizontal by about a 45-to-1 factor, and so the real topography of the moon is not nearly as jagged as it appears here, but the effect on grazes is quite interesting. Next slide. Okay, well, this is just talking about multiple stations, which I talked about a lot yesterday, so I think we can just skip this one. I just mentioned this one, 1968 was the first, idea. And then in 2011, December 21st, we had a good success with this 4th magnitude star Tau Aquarii. Next slide. So anyway, there were 3 unattended stations up here, and another one, a pair down here that Alin Talia ran. He was also an observer at the Antiope, or Agamemnon occultation, I mean. But he ran a remote station and then observed with a pair of binoculars about 100 yards from his remote station. And then a few of us, so we only had 4 observers, but we were able to run 8 stations then. Next slide. And these are challenges. These were mostly tracking telescopes. There was one that was just a camcorder that was sensitive enough to record the 4th magnitude star. And so that was just on a tripod, and where I just aimed it ahead of the moon about half an hour before the event. But the others all were tracking telescopes. Next slide. Okay, next slide. It just shows this station had 5 Ds and 5 Rs more than any other, although it was smaller. And then Scotty, though, developed the Mighty Mini and MIDI systems. These are great for asteroid occultations, but for the moon, they're not so good because of the bright moonlight and the wide field of view. For lunar occultations, you want a narrow field of view where you spread out the moonlight enough and get a good view of the star. But if the moon is a thin crescent, it's not so bright, and if the star is bright and it's on the dark side of the moon, these systems will work for that, and that has an advantage of being able to spread out a lot of stations that you can't normally do for a graze. But next slide, this just shows slides I showed before, so just quickly go through those. And next, that's the MIDI. Okay, next slide. And the maxi. Next slide. And the first success I had really using Mighty Mini systems was that for an Eta Geminorum back in April of 2011, the first good success, the third magnitude star, it was 36% sunlit moon, 15-degree cusp angle, so it was quite good. Anyway, the next slide shows there were some weather issues. Normally in Arizona it's clear, but it wasn't that night, and the sky cleared up about 70 minutes before the occultation, so I rushed as many. I was hoping to set up more, but I got 4 stations set up, one intended just to be a attended station, but I got 3 remote stations all running in the graze path here, but at the attended station, and by the time I got there, because of various problems I got on the moon, just about a minute too late. So I, yes.
You made a comment that the Mighty Minis are not similar to this. These were
No. This is the difference. Now, we are using Mighty Minis. They're not normally, for most grazes, they're not. But for grazes like this, where there's a high enough signal-to-noise ratio, where the moon is faint enough and the star is bright enough, it does work. And so I've been pushing the limits since then of how good we can do. And in addition, trying to get as many multiple events. This was just a general deployment. This wasn't trying to hit any special area of the profile. So that's what the newer work has been trying to make a tighter deployment in a narrow area to get the more multiple events. Next slide. Yeah, I mean, it's used just the same way that we do for the asteroid occultations. You use pre-point charts, and you just point at the altitude using the pre-point chart and the line of declination with the times marked on it. You just I explained yesterday for the asteroid events. You can do it also for lunar events, the same way. Anyway. We had a good opportunity a year ago in August 2012, and I talked about that at the last meeting. So in this case, I'll just show the next slide. We had 4 stations set up, and the 2 attended ones had trouble, mainly partly because of getting there on time and something, but the 2 attended stations worked fine, and one of them was hit a kind of flat area where we got 6 Ds and 6 Rs with a Mighty MIDI system, an 80 millimeter. Anyway, this is just to show Kaguya, and also we have lunar reconnaissance orbiter profiles now. This is an analysis of that April 10th Eta Geminorum graze that Dr. Mitsuru Soma did, and unfortunately it doesn't include my observations yet. There was a big expedition in Northern California, and actually 2 expeditions there that recorded these observations from a total of about 15 stations. So you can see how the observation points follow the predicted profile extremely well, so much better than the Watts ever did. So the Kaguya profile extremely accurate. You can see there's just one place here where The Kaguya profile dipped down here, but the LRO showed that the followed those points. And there's just a couple of places where that the LRO is slightly better than Kaguya. And every once in a while you'll see in the Kaguya profiles that we have in the predictions, you'll see a bad point, and so there'll be a valley like 2 kilometers deep or something, but it's just one point, and you can spot those and just ignore them. But now with both the idea of multiple stations and with this LRO and Kaguya data, there are still new things that we can do with grazing occultations that weren't possible in the past. Next slide. Okay, this was in May this year, a graze that occurred on Mother's Day evening. It was the 13th UT, but it was the 12th local time. And so, of course, it was everyone and his mother wanted to see their mother. So I managed to convince to have dinner, very early, and then I rushed up and observed this graze. Anyway, it was a thin crescent moon. Next slide. In this case, it was a faint star. It was too faint to do with middies or anything, so I just used an 8-inch telescope. I tried to hit this this area right in here. Okay, yeah, okay. There's an area between just before the 0, the middle of the profile, and those are minutes. To the left is minus minutes, -1, -2, -3, and 0, +1, +2, and +3. And between -5 seconds and +40 seconds approximately is a flat area of the profile that I was trying to hit to get into that area. So next slide. It just shows the path going across Baltimore and north central Maryland. In this area here. Next slide. This is where I went. This just zooming in more on the area. Next, there's Finksburg. Next slide. And this shows between the 2 gray lines is where I thought the path would be, and I wanted to observe in the lower right corner there's this big open area here with the Gestel Academy. But when I got there, I found there were gates, so this whole area was locked, so I couldn't get into there to get into an ideal spot. So instead, I observed right in the center of this figure, right above the 140 that's in the center there. There's a public land and a narrow strip between a frontage street and the main highway. So I was off the main highway, with a fence on this frontage road, and so I had a good observing location there. And I was in the southern part of this multiple event zone, so I thought I would have a lot of events. However, the next slide, I think, just is a summary of what's happened. So I only had one disappearance and one reappearance, and that was during the early part of the graze, and so the star missed that whole flat area that I was trying to get in. And the problem was because I used a height above sea level of 50 meters, which is what it is in my home. And of course, Maryland's flat. You don't have to worry about height above sea level, right? However, but Finksburg is on the west side of the fall line. There's a fall line that goes along the eastern coast, and all the ports there are on that fall line. Because it's rocky and you can't navigate beyond the fall line. The Great Falls of the Potomac River is just to the west of Washington, D.C. So that's why Washington, D.C. was put there, so you could get ships in there. But on the other side of the fall line, it's quite a bit higher. So the height is 200 meters, and that was enough in this geometry to shift the multiple events in.
When you say fall line, you're referring to waterfalls?
Yeah, well, it's there. there's waterfalls where the rivers go over them, and the Great Falls is, has about a 70-meter drop there. But it's also it's just a geological term for a fault line, where the elevation drops. But of course, there's a much bigger rise as you get to the Blue Ridge, but that's many farther west. So anyway, in this graze, I learned more about the topography of my home state than I did about the moon. So, and Mitsurosoma's analysis of the timings indicated an additional shift that's likely due to the star's proper motion. Next slide. Next, I had to do some time in Russia, and so there was a graze of a nice bright star there. The town closest is this Mozhevskoye. It's about 50 kilometers southeast of Voronezh, and it's about 600 kilometers southeast of Moscow. So it occurred at 4 in the morning with a bright star and everything. So, I teamed up with an amateur astronomer who lived in the city of Tula, 200 kilometers south, and so I just go through the adventure here quickly. Next slide. And again, there was a flat area we were trying to hit, so we tried to navigate to that in southern Russia. But it knows it's close to the cusp. All these grazes so far have been close to the cusp. We haven't had nice big graze, large cusp angles like we did for the Eta Geminorum graze. But I was planning to go to Kharkov first in Ukraine, but where we could get other observers. But this was the predicted cloud cover there, and this was the area we were headed towards, about 30% cloud cover. And so the Skippy sky, we said, okay, it looks good enough, let's go. Although the Meteo Blue forecast said it would be overcast the whole time. So sort of tricky to predict weather in that part of the world. Next slide. This just shows quickly how I walked 700 meters from my apartment to the metro station with a suitcase like that holding 2 middies and the equipment. Next slide. And I took the Moscow subway ring line up to the Kurskaya train station, where I met one of my students who translated for me and got me the right train ticket to go to Tula. Next slide. And now this shows Moscow at the top, and you can see near the center of the figure is the city of Tula. So I took the train down there and then met Vladimir, and then we drove first on the M2 highway, then the P141, and then the M4 highway. So next slide. This is just leaving Tula. There's the Tula train station in the background, and this is Vladimir's little Russian Lada car. He has his own telescope in the back there, and we got my suitcase in his little trunk there, and so it worked. Next slide. And he didn't speak much English, and I didn't speak hardly any Russian, but we were able to communicate enough for this long trip. So anyway, this just shows a little bit blow up of the area getting closer. Next slide. And this just shows driving in that country, sort of like driving in the Midwest here, and with lots of open country, and see open spaces there. It's increasing farmland as you go south. And this is churches at one of the cities we drove through. Next. And this shows a thunderstorm we saw. So this didn't look too good weather-wise. In fact, we drove through that thunderstorm. You can see the M4 highway is an interstate quality highway. So it's quite good. We could make good time on this. But at Voronezh, there was a lot of construction. It took some time to get through there, but then it was good quality again getting down to here, the path. Next slide. This just shows the path in more detail. That narrow zone just happened to cross the exit to that town, and there was this farm field just to the right of the highway. And the farm field had a dirt road going around it, and we were able to get up into that zone there. Next slide. And this just shows one of my middies. We set up, he set up his telescope near his car, which was at the best place we could get. We were able to get within 12 meters of the place I wanted. And then I set a middy about 60 meters south, north, and another one 60 meters south of where he was. Next slide. And this just shows, here's the star. You can see the star just to the right of the northern cusp of the moon in this view that was taken after the grays. You can see there's a little bit of haze. There was some thin cloud over the moon, and that pretty much wrecked the view from the middies. But when I played the tape back closely, I could see the grays events. And there weren't very many because, again, we were a little too far north. The actual path shifted south, although I know we were in the right place according to the GPS measurements. So this was a case where the proper motion error of the star had a problem. So next slide. This just shows after the grays, showing Vladimir's 5-inch telescope, and he got a good recording, a long focal length telescope. But he didn't have a drive on this, so it's sort of jerky his view, but he got a nice recording. You can see the blue color of the star versus sort of the yellowish color of the moon. You can see the clouds that we were dealing with. Next slide. And this just shows Vladimir and me standing. He put it on a tripod, and we set up the middies before we took them down and put them in the car. Next slide. You can see the lights of the interchange in the background there. So anyway, we had 3 Ds and 3 Rs, but we should have gotten more events if we really hit that sweet spot. There was just one event that was in the sweet spot area, 1 D and 1 R. So it showed, again, the path shifted a little south. Next slide. Okay. Then on August 2nd, we had another graze of a 6th magnitude star, but again with a really bad cusp angle, but a 17% sunlit moon, and it was at a decent altitude above the horizon. And Joan and I both drove down to observe this from the parking lot of the Hanover High School, Mechanicsville, which is a suburb 15 kilometers northeast of Richmond. So it's about a 2.5-hour drive from our home in Maryland. Next slide. This shows the profile, shows how it's one of these flat top things, and so there's this nice area that's about about 150 meters wide or so, where there are multiple events, and then the rest of the profile is less interesting. So obviously we want that parking lot area. You see the next slide shows where that path for that multiple event zone goes. Yeah, there you go. Okay. Okay, this just shows the path across Richmond. The downtown Richmond is down here, but this was up where we were along close to US 301. Next slide. And this shows how the high school was just perfectly situated to cover this zone, and it was just a perfect site. So we were off the highway, so we were in this parking lot at 3 in the morning. There was no one there to bother. There were no security guards or anything. And they also, lo and behold, they turned off all the lights in the parking lot. I guess they're actually trying to save money for a change. And so it was dark, it was clear, and there were no mosquitoes or anything. Now, the only problem was there was a fox near this northern station up here that kept barking at us in this horrible rasping bark, but we were afraid it would attract attention. But we set up the a maxi here, and then an 8-inch telescope that Joan ran here, and then a MIDI here, and I had another second maxi down here, but by the time I got these guys all running, I got to that one just a minute after the graze. So we got 3 successful stations, and it all worked quite well. And we really hit the sweet spot this time. This event, this station I think had 8 Ds and 8 Rs. This one had 7 Ds and 7 Rs, and this had like 6 Ds and 6 Rs plus a blink. I'm still in the process of trying to analyze the data. I want to get a plot of that. This is the first real good success with using these small scopes. But the video doesn't look real good. It's on YouTube, but because it's so close to the cusp, you just see the star coming out of the cusp and then the events occur. So next slide. This is the waning phase, so the star goes over the cusp and then anyway, I already mentioned here what the results were, and the accurate prediction in this case finally enabled us to hit the things. But you can't always do this because of the proper motion errors. You have to allow at least 100 meters of error, in these things. So anyway, I'll show some grazes that we have on YouTube. We'll just go to the YouTube site, but I want to show next. I want to go to the ESOP, the European Symposium on, there's the ESOP 32. Oh, question, okay. If we provide a call with a credit, yes, that's, Ted Swift's question is correct. As long as you have the right elevation, you should be okay. And you guys in California did very well with the Eta Geminorum graze. You guys were in the right place. And there was another graze I know that where you kind of hit the sweet spot with